So I've got the 289 block mounted up here on our RMC 1000 boring and surfacing mill. And if you guys watched the teardown video, you'll remember that number one cylinder here has a little bit of rust in it. Of course, the block at this point has been baked and we've glass beaded it so that it's completely clean. We got a little bit of surface rust that came back after washing it after that process. But you can see that even after cleaning all that rust off, we still have a fair amount of pitting in the number one cylinder, and even the number two cylinder here actually has a little bit of pitting there. The good thing on the number two cylinder is almost all of that is above the ring travel, so it would never have any effect on the sealing of the piston rings. But to start with, we're gonna set up our cutter. We're trying to keep this block at 20 thousandths oversized. So what I'm gonna do is set up a cutter and start down through here, and we're gonna see if this is or is not going to clean up on this number one cylinder at 20 thousandths oversized. And if it's not, we're gonna have to install a cylinder sleeve. So we wanna get our cutter set up here. This is what the cutter looks like. So it's just a little diamond shaped cutting insert. And that goes here in the boring bar. If you're not new here, you've seen this before, but if you're new here, when you're boring a cylinder, you know, say we're gonna go 20 thousandths oversized, we're actually only gonna rough bore it to about 15 thousandths oversized, and that last 5 thousandths we're gonna take out over here in the cylinder hone, and the cylinder hone does a little bit nicer job of hitting that dimension right on size and getting your bore geometry correct, but the other thing that it does is get your surface finish correct. So that being said, we need to set this cutter to about 15 thousandths over the nominal size of 4 inches. So there's 4.0, just under 15 actually is what I've got it set to right now. But I'd rather cut it a little bit under than cut too big. The way that our fixture here works is the block sits on these rings to center up on the crankshaft center line, and then this triangle piece here actually goes up against the pan rail of the block to get the deck surface perfectly aligned with the spindle. Then when we flip the block over to the other side, it'll get the other deck surface exactly 90 degrees to the first deck surface. The only place that this fixture is lacking is it doesn't take into account the center line of the camshaft. So we may be slightly off center from the center line of the camshaft, but this is probably pretty similar to the way that this block was manufactured when it first came out of the factory. Put the centering finger in. So I just wanted to run the gauge up and down the cylinder and make sure that our needle didn't move a ton, to make sure that we are aligned well. So you can see that needle barely moved there until we get up on top of the ridge. And as far as being centered, we might be a 1/2 thousandth, but that's about as good as it's gonna get. So our goal here is maybe go down, I don't know, inch, 2 inches, and see exactly whether or not we think this rust is gonna clean up. Okay. I'm gonna run 5 or 550 RPM because this is a really light cut. Wow, that cutter must be duller than dull. So that left a terrible surface finish. That cutter I was using apparently did not have as good of an edge as I thought it did. When I checked with the bore gauge, it still cut right around where we would have wanted to be. But all of this here is still that rust showing through. When that rust starts eating into a cylinder, you have to go extremely deep to get past all of that rust to where you have good metal for your cylinder wall. So we're going to go ahead and put a sleeve on this cylinder. On cylinder number 1 here, we have, 50% of the cylinder here, and all the way down a few inches down is going to have that rusty material. Whereas on this one, 90% of that little spot of rust is above the ring travel of the pistons. So it's not worth putting a sleeve in this cylinder. This one will be fine. But over here where we have so much extensive rust, we need a cylinder sleeve to fix that. So the great thing when you get a cylinder sleeve in, they're never round, they're never straight. So you kind of have to measure multiple points and then take an average. And that's kind of what I've done here. So 4127 and 3, 4128 and 3, 4127 and 6, 27 and 3, 27 6, 27 6. So I'm going to say on average, we're a little bit over 4127.5. We probably want no less than about 1.5 thousandths press on this, but if you get more than about 2 thousandths press, it's going to start to get into the realm of getting hard to install. I'm going to say that we need to bore our nominal size for the hole to about 4125, or let's see, 4125 and 5/10. So our standard bore size is 4 inch. Our sleeve measures 4127.5 on average. I want to have a 2 thousandths press fit, so I need to make our hole 4125 and 5/10. I'm going to do this in 2 cuts. Going from 4 to 4125, we realistically could do that in 1 cut on our machine, but it's just a little more wear and tear on the machine and maybe not quite as accurate. So I'm going to do the first cut to 4095.5. So that's going to be a 95 thousandths cut. And then the second cut, we'll do a 30 thousandths cut to our finished size of 4125.5. First rough cutter here, 4.050 45. So that'd be 95. It's a little bit under what I said it was going to be, but it's a rough cut. And this one should be 4125 and maybe just a little. And that one is a brand new cutter. I went through and I set our stop here on the machine so that we won't bore down past, because we want to leave a lip at the bottom to press our sleeve against. In theory, the press fit would be enough to retain the sleeve in place, but by leaving a ledge at the bottom for it to sit against, we know that the sleeve can't move down, and obviously it's not going to move up because you're going to have the head on top holding it in place. I actually have a little washer in here, and that'll stop the machine a little bit before the depth that I actually want to go to, and then I'll do the last few thousandths by hand. Okay, this is going to be a bigger cut, so I'm actually going to slow down to, we'll try 420 RPM. That looks about right. You could still hear that rust at the top. I'm going to restart this, and I'm going to run down to 4.8125. Looks pretty good. As you can see, we're leaving a step there at the bottom. So it's actually counterbored on the bottom, and our step is about 1/8 of an inch above that. It's all going to be seamless once the sleeve is installed. You probably won't even be able to see it, but you can see that we're leaving a little bit of a ledge there for that sleeve to sit against. Let's do our second cut. 90 over would have cleaned it up. Looks pretty good, so we'll let that run through. We'll just go a thou farther. It's a little bit nicer finish. Okay, so we've got oil on the bottom and then oil on the top of the block itself. Then Loctite on the bottom of the bore in the block and Loctite on the top side of the sleeve. Okay. Obviously the sleeve is about almost twice as long as it needs to be, but that's okay. The reason we're not using any liquid nitrogen or heating up the block, A, it's a pain in the butt. B, it's expensive. You just don't really need to do it for one sleeve. Right. If we were doing all 8, that's when we've used it before, but for one sleeve you don't need to. When we drive this in, we can just go straight to machining it, whereas if the block is hot, sleeve is cold, you gotta wait for everything to equalize.
Right. It's just not cost effective to do it for one sleeve. 8 sleeves, yes. 1, no.
Pretty good that way, but
a little bit still to the left. A little bit towards you. Okay, you're about to the Loctite.
gotta be like there.
One more. There you are.
I didn't need you after all. That felt like the right amount of press.
Yeah, it went in nice.
It's funny because that's something you just cannot explain to the camera whatsoever, but it just felt, you can just feel that was the right amount.
But yeah, there's a lot of stuff that after you've got some experience doing this, you just know by the feel when things are going right. Put the level on it again, just make sure nothing's shifted, but that usually works pretty well for us to do it that way.
Oh, you got a letter over here from the small red Department of Labor and Employment. Should I open it? Probably. That still looks good. All right. The nice thing, like, yeah, we get comments, and we agree, it's not the greatest to be banging on a machine like that, but the nice thing with the way the fixture is designed, we're hammering directly on center with the main bearings the way they're supported. So generally nothing moves, and I double checked that everything was still tight. At this point, we need to center up on this cylinder, we need to trim off the top, and then I'm going to bore it to the standard 4-inch bore size, and then we'll go through and do our rough overbore. Let's just get this centered up real quick. It's just a few thousandths different. It's not anything worth getting excited about. That'll do it. So now this cutter I've set up to 4.2, so it's sufficiently bigger than the top of that, and we'll trim this sleeve down. Nope. We're gonna recheck things after that. I'm gonna have to hand feed it because that was just too big of a cut to power feed. Now this sleeve, the ID right now is actually 3.9375. So I'm gonna rough bore it to our 4 inches, and then it'll be like we're starting on a fresh block. Should be good to go. So now I've got our cutter set up to our 4015 rough bore size. Let's see how this goes. You can always buy another sleeve. Sounds good, looks good. I think we could speed up our spindle, 500 RPM. Now we let it run. Let's see how we did. About 3 thousandths left to hone, which again is enough, but since we are going to put a torque plate on here, I don't expect this block to distort a lot because it has small head bolts and they're actually spaced out pretty far away from the cylinders. But I'm going to adjust that cutter about 2 thousandths, maybe smaller. At this point, the bottom of the sleeved cylinder pretty much looks the same as every other cylinder. And that's the goal when you put a sleeve in, make it look like it's not even there. One last thing we need to do here is put a little bit of a chamfer on the top of this cylinder so that when we install the piston rings, we don't have issues. So let's set up a cutter and do that. Probably going to call it there at -170 because we are going to take more material out of the ID. We're also going to deck the blocks so that will get a little bit smaller, but I don't want to make it too big. We should be able to whip through all 4 of these, and then we'll deck this side of the block, roll over, deck the other side, and bore the other side. Ooh, that was close. I'm going to start with chamfering. That was a really nasty chamfer on it from the factory. So this is that cylinder that had some rust at the top as well, and it is barely there. No reason to put a sleeve in this cylinder. I mean, there's a little hint of it, but there you can see it a little bit better in the light. There's a near 0% chance that that still shows after we hone this block. That looks really good. Chamfer to -170. Man, the factory chamfer is ugly on these. It's almost like it was done in 1960. Alrighty. Cool beans. This is what I was talking about. I don't know if you guys could see it, but look at how much factory chamfer is left here versus where my chamfer is over here. If they hadn't put that, or if it was even to the cylinder, it would look, well, it would look like the sleeve does. Nice, even chamfer all the way around. But that is not how the factory chamfer looks. This one was pretty close because it just left a little spot there. Totally fine. It's just cosmetic stuff. But, so this cylinder, we're talking 3/1000ths to finish, 5/1000ths, 5/1000ths, 5/1000ths. So we're in a good spot. Now we need to deck this side of the block, so we're going to switch over to our surfacing head. That's about 3/1000ths. Right there, we just barely skimmed, minus 5.1785. So just for fun, let's do a 2 thou cut. So we'll go to minus 5.180 and a half. Huh. It's kind of interesting. So we've got some kind of waviness here, but we touched dang near all the way across over here, kind of from here over. There's a little bit skimmed right there, kind of a spot here, a wave here, and then same thing, kind of a wave from about here all the way to over here. So we may be ever so slightly tilted from the way it was surfaced at the factory, but nothing crazy. Again, we only took about a real light 0.002 off this, but you can see it's got some waviness to it. So let's take another 2 or 3 here and see what it looks like. Wow. We've got a little bit of shadowy rust over here where the gasket, I think, does not touch, and maybe there was a little bit of water, just a little bit of corrosion. But our sleeve cleaned up all over. I think everything is clean here. So I'm gonna do a 1,000th finish cut, nice and slow, and then we'll roll over to the other side. So on the z-axis here, we're at minus 5.1835. I didn't re-zero since we have our zero marked for where we want to cut our chamfer to when we flip back over to the other side. But hopefully when we flip to the other side, we can deck to that same value, and hopefully the opposite deck will clean up at that same value. If it's within a couple thousandths stock application, it's perfectly fine. If this was a performance application and we were going to zero deck the block, we would definitely want to have them within a 0.5 of each other. We usually try to get them almost exactly the same, but as long as we're within a few thousandths on a stock application like this, it's not going to make any difference on the performance of the engine. We're down to our 1,000 finish pass. And I'm gonna go eat lunch. Purdy, purdy. So brought it down to the same value on the z-axis there on the DRO, And what that means is the distance from the top of the deck to the center line of the crankshaft should be the same as the opposite deck over here. So at this point, let's switch over to the boring head and we'll go ahead and bore these 4 cylinders. Damn, that looks good. Last hole, it probably won't clean up. Well, that was boring. Okay, I'm gonna get our mess cleaned up here. And then there's one more operation we're gonna do on the block before we go into the cylinder home. So this early 289, the block is designed for a 2-piece rear main seal, but we can actually convert this over to a 1-piece rear main seal by boring out the rear main cap a little bit larger. So the block is mounted up here and we're just going off the front face of the block and we're centering up on the rear main cap here. This seal, the biggest thing with getting this to seal is going to be having the seal installed concentric to the crankshaft center line. So by centering up on the rear main here, that should get us nice and centered to cut our counter bore that the seal cuts into. We're essentially cutting away this outer lip where your 2-piece seal would fit. I've got the block bolted down with 1 bolt through the cam bore back there that's kind of hard to see, and then this bolt right here through the mains. We've got our centering finger running there. I had to go kind of towards the bottom of that bore to avoid the oil holes because it makes a pretty big mess of things when you drop that centering finger into a oil hole. And you can see here, that needle is running pretty well dead nuts true, which is going to be more than enough for this seal. The seal is going to be fairly forgiving. Currently, that bore is 3.688 roughly. I'm going to do my first cut to 3.888, my second cut to 4.088, and that's going to leave me roughly 150 thousandths left to get to our 4.4242. I got a number anywhere from 4.240 to 4.245, depending on who you ask. So we're going to put it right in the middle-ish at 4.242. And I'm actually going to do that in 3 50 thousandths cuts, coming back and adjusting my cutter so that if the mic, I haven't used this boring head in a while, and I'm not entirely sure how calibrated this mic is. So by doing it in 3 separate cuts, that'll give us a couple different opportunities there to make adjustments based on what this, based on what the mic reads, so that we can sneak up and hopefully hit that 4.242 pretty well right on the money. But again, there's kind of a 5 thousandths tolerance there depending on who you ask. Okay, so one guy said 415, one guy said 420, and one guy said 450. Let's just go 420.
I was going to say, I think 420 would be good to start with.
There you are.
Okay.
Our next cutter is 4088-ish. Sounds ugly, but it looks all right. Okay, we're 4142.5 now. Coming up 141.5. And we thought we were going to be 142.5. So on 192.5, let's set it to 193, which I'm hoping will give us 4192.
Somewhere on our walk, your daughter snagged my phone,
And it's gone?
and it's gone.
Okay, so I'm getting 4191 there. Let's start trying to go to 4.217, which probably is actually going to cut more like 4215, and just see if it cuts a little bit nicer. Yeah, just like the last time, we're about 4215, even though it was set to 4217. All right, this should be our last cut. I think that looks actually really nice. If I'm not mistaken, that looks a lot like 4.242 to me. I'm just gonna break this sharp edge here on the top in case anyone ever wants to try to install a seal with the crankshaft in the block. So doing that leaves a real nasty edge down here. I mean, real sharp. And we don't need this full area for that seal to seat against, really. So I'm gonna set up a cutter and we'll go in and start to take some of that out. Let's go like 30 thou bigger. think we're going to call that good. I think that came out really nice. Yeah, I'm going to install new dowel rings. And now, let's maybe put the main caps on and get it in the hone. We're going to go ahead and torque down our torque plate to simulate the distortion that will happen when the cylinder head is bolted onto this block. Now you might remember this is not a high performance build, but we want to do the nicest job we can, so we're going to go ahead and use a torque plate anyway. There you have it, just for funsies. So we've got the 180 grit diamonds in. That's going to be our roughing. Not sure how well the camera will be able to see this, but we've got 5.5 to 6-ish to go to our nominal finish size of 4020. We still need to measure the pistons and double check that that is where we want to go to, but we can start getting things roughed in here. I really don't think there's a lot of distortion there. I mean, you can see a little bit more purple in certain spots, but it's definitely not like the 400 small block Chevy that we had in a short earlier in the week. And I don't even think I took half a thou there. Show you here. That needle is running very true, which usually is a pretty good indication of how straight and round of a cylinder we're getting. I set it to run for maybe 0.004 of an inch. All right, let's see how it's doing. Okay, so that cylinder we've got 5+ to go. This cylinder we're 4.5, or 3.5 rather. Pretty dang straight. I'm gonna set that and I'm gonna get ready to go measure our pistons. Right now, it should be taking that last 3.5-ish out. It'll do a little bit less than that, but we'll let it run. I was getting maybe a couple tenths tight just in the middle of the cylinder. So I shortened the stroke length a little bit so that we overstroke less out the top and bottom. to measure all of our pistons and just make sure that they all look okay and that they're about the right size. Silverlight says that they should measure 4.0187 plus 0 minus half a thousand. So anywhere from 40182 to 40187. Looks like we're about 40186. I'm going to say we're right at 40187, 40186, 40183, 40187, 40184, 40186, 40187. They're recommending that we finish the bore diameter to 4020. That would be 1 3/10 clearance, which is kind of pushing tight for our comfort. They are a hypereutectic piston, so they do expand less than, obviously less than a forged piston, but on top of that, less than a cast piston that is not a hypereutectic piston. With that being said, I think we're going to go ahead and add a half a thousandths to this recommended number, and we're going to size it to 40205, just to give us a little bit of extra peace of mind. It's kind of the old saying of too loose and we'll know, too tight and everyone knows. The problem is we post this on YouTube and too loose, everybody also knows. So as I've learned more with these diamond stones, on this machine, one of the things that really affects the consistency, it seems like, in our surface finish numbers is how much pressure or how much load we have on the load meter when it finishes honing. And when we're letting the machine just continue to feed out to the finished size, depending on where the mechanism is and where it ratchets when it gets to 0, the load could be, as low as maybe 20, or it could be up above 40. So I figured out what I can do is take the last few tenths in each cylinder manually and try to manually control the load right around 40 for the rough stones. And that just helps keep things consistent from one cylinder to the next, it seems like. So I'm going to take about 5 strokes here if I can, trying to hold it pretty close to 40. I guess this is where a new CNC hone would do better, but joke's on them because they spent $100,000 and I spent $10,000. So right there at the top, we're about a 1/10 tight. I'm gonna give it 5 more and call it. I think that's pretty dang good. One, two, three, four, 5, 6, 7, 8, 9, 10. I shortened the stroke, and I think I overshot it, and now I need to go halfway in between because now, if anything, I'm getting slightly big in the middle. But I mean, we're still talking tenths, not.
That's the nicest 289 they ever came out of here. That first side or second side?
That's the first side. So 0 is our half over.
Okay.
So I figured even if I'm
5/10.
I would say I would be fine even another half over that. Pretty dang good. Better, more round than they ever came out.
Mm-hmm. No, that's the ones I used to have to cut off the stones to try to get the middle.
Okay, so now I'm going to put the 600 CBNs in. And I think the other day on that 400 I did 13 strokes. And it seemed to put me right in the right spot. And for this, I'm going to try to hold the pressure right at 30. I'm actually going to listen and try to hear when it first touches. 5, 6, 7, 8, 9, 10, 11, 12, 13. So that might have increased size 0.2. .42 RK, 12.7 RPK, and 47 RVK. My RVK is a little bit low, but it's not bad. What'd you buy for rings on this?
Just Molly, standard set Molly factory replacement rings. A Molly top ring, cast second ring.
Yeah, so it's not a steel-coated ring. It doesn't necessarily need the deepest valleys. And we're right there on the edge, actually, 42, 47. I wanted to try to show you the difference between a finished cylinder and a roughed-in cylinder. And unfortunately, I don't think the camera picks it up as well as it actually could. But this is a cylinder that we finished with the rough stones, so it has not been plateaued yet. This cylinder here, we've finished. This one feels rough, whereas this one just feels smooth as can be. I also went in and I took 4 different measurements at 90 degrees apart on that cylinder. And you can see we're pretty consistent. We had one that the valleys were a little bit deeper, but overall our numbers are fairly consistent, coming out to an average of 43 on the RK, 15, almost 16 on the peaks, and 53 on the RVK. So we're pretty well perfect for what this application is. So I think I'll go through and take my 13 strokes on these last 3 cylinders. We'll double check everything, and then we'll flip over to the other side. There you have it. I've got the rough stones back in. Let's just run through, bring these all to size, switch over to the finished stones, finish them out, and I think I think that's going to wrap up machine work on this block.
Hey, what are you doing?
Waiting for you to show up for work.
Been out farming today. So it's the weekend, I get to play farmer. So, hey, last night, Mom took me, or I took Mom, not sure which way it was, to the Route 80.
Who's the breadwinner at this point?
Probably Mom. Anyway, we went to the Route 85 grill there in Eaton last night for supper, kind of late, and I got spotted in the wild.
Yeah.
There was another family at a table next to us. I think it was a grandpa and probably some of the kids, and maybe a grandson was there celebrating Grandpa's birthday. He said his name was Don. But anyway, they were followers, so they spotted me there, started asking if I was a machinist, and they were thought fast enough where I'd have told them I was just a cleaning guy.
Yeah.
But anyway, I wanted to let you know that and tell all of our followers that I give a shout out to Don there. Wish him happy birthday. It was kind of funny.
Nice. Yeah, I never get recognized.
Well, you don't spend enough time in front of the camera. You're the one usually behind filming me instead of filming yourself standing here doing what you're doing.
Well, today's video is pretty much all me, so.
All right, with that, I'm going to go farm some more, see if I can burn some more diesel in that old 210 Alice.
Okay.
See ya.
See ya. We're going to do exactly like we did on the other side. Basically, I'm going to listen, and when I hear the stones start touching, that's how much load I'm going to run and do 13 strokes here. I'm trying to work, and the cleaning guy's watching TikTok.
Well, I saw something cool.
Okay, that is pretty cool, though. Cylinder 4? Is that where we're at? Yeah, cylinder number 4. Came out 52 RK, so that's a little bit higher than the other side. RPK 14, that's about where we are. RVK 61, it's a little bit deeper than the other side on average, I think, but those are still good numbers for what this application is. Cylinder 3, so those numbers are almost identical to what we had on the other side. 45 RK, 13 RPK, 56 RVK on cylinder number 3. There's a pretty picture of it. That's what you want to see, is nice and flat on top, but still kind of the deep valleys. You don't want, if this was the top, you don't want it to look like that, because then you would have shallow valleys and tall peaks, and that's the opposite of what you want. Cylinder 2, just under 40 on the RK, 12.5 RPK, 62 RVK. So now we're on number 1. This is our sleeved cylinder, and sometimes a sleeve can machine different than the rest of the block. I mean, it's a different material composition, so it would make sense if the same process maybe yielded a little bit different numbers, but hopefully they're within reason. We're about to find out here. A little bit lower RK, but we're still right in the ballpark on our RVK and our RPK. Again, it's a stock 289. It's nothing crazy, but we always try to do the best. I mean, I put the profilometer on our tractor engines when we do a tractor motor. The video isn't out yet, but we did a 1940s LA John Deere. Pretty sure I put the profilometer on that as well. And, you know, we try to do the best that we can, even if it's an application that some of your other shops might just say, oh, it's just a stock engine, who cares? Well, we do care. Plus, we're putting it on the internet for hundreds of thousands of people to criticize, so there's that too. You know, for me, the hone used to be the most frustrating machine in the shop, because you would do all this work on a block, and you get it into the hone, and you start honing on it, and you fight it. You got to stand there and baby it. And just when you think you understand how to make it do what you want, some unexpected variable pops up, and you would spend hours in front of the machine on a block and have it come out worse than your standards. But now I love running this machine. It is so much fun and so satisfying when you get that perfect result you're looking for. I love that unless you know that sleeve is there, I don't think anyone could tell. Too bad the whole world knows there's a sleeve there. And our other cylinder that had some rust on it, it cleaned up completely. So I'm glad we didn't go to the trouble to try and put a sleeve in the second cylinder as well. Okay, let's get this into the wash cabinet. So I did go in and also did a little bit of kind of sanding to take off. Some of these have a little bit of a sharp edge at the bottom of the cylinder, and you don't want to leave that in case the piston skirts do pop out the bottom of the cylinder, which on some blocks they do. I don't remember exactly for sure whether or not they do on this, but you don't want to have a sharp edge at the bottom of your cylinder that'll wreck your piston skirts. So I kind of took care of that, and now we can go in the wash. I don't know if we talked about this, but we put a new door. We had a new door made for the spray cabinet here, and we modified the table down here so that instead of just a wheel that friction drives on the table, we have a nice kind of a cog back there, gear, and that drives on this chain here and drives the table, so it does a better job of keeping everything rotating. So that's cool. To start with here, I'm going to try to brush through the oil galleys. Now this brush may not be very easy to run on my own, especially since I am not a very experienced cleaning guy, and the real cleaning guy is out in the field. Ow! I feel like I'm a plumber now. But at least poop doesn't come out on my brush. I'm gonna brush out the cylinders real quick, and then I'll start the spray cabinet again for a couple minutes. And then we'll get the block out and rinse it and be done. Woo! Doing that should help get some of the honing, remnant grit from honing out. I'm really happy with how this block came out. Looks quite a bit different than it did when it came to us. We did get the Teflon coated bearings. I don't remember if I included it in the teardown video, but my dad mentioned that as these got to higher mileage, it seemed like the stock cam bearings, they had issues with the bearing material starting to flake off. So we figured, especially if we're going to go to a roller cam, but even if we're going to stick with the flat tappet cam, we go ahead and get the coated bearings, just to give it a little bit of an upgrade. We're ready to put the rest of the plugs in, but I'm out of time for today, and we're just going to have to call the video right here. This thing is looking very, very nice, though. We've still got a little bit of work ahead of us, but at this point, we're well on our way to having a 289 on the dyno. So be sure to like, subscribe, and stay tuned.